Okay, hi guys. So in the previous lecture, we saw some good reducing agents like LaLH4, and today before starting up, we will be writing some notes on the same. And we also saw some reducing agent like NaBH4, but I didn't get much time to talk about it, so we'll be covering up that also in this lecture. Okay, so let's get started. So we have first notes as first point would be that NaBH4 will reduce aldehyde, ketone, acid chloride, and halide, primary halide. Okay, so will reduce aldehyde, ketone, acid chloride, and halide 1 degree. Okay, statement 2 would be that nitrogen containing compounds such as amide, cyanide, isocyanate, NO2 will convert into amine. Okay, this is in general, and specifically or generally for LV will be using this statement for LiAlH4 or simply LAH. So nitrogen containing compounds such as amide, cyanide, isocyanate, NO2 will convert into amine. Okay, so next we'll be seeing some famous reduction processes. Okay, so so we have first cyclohexene ring. Okay, and if we try to reduce it by providing some H minus with with either LaLH4 or some other reducing agent, it would have no reaction. Okay, second is if we have something like a double bond here and a ketone group here, and again we reduce it with LaH, or we, in other words, I provide H minus to the compound or to the substrate. What will happen is uh, this H minus would be attacking this C, because obviously this is partially positively charged. Okay, and we'll get something like and obviously this bond will be shifting to this one. Okay, and then this O minus or the bond between C and O would be getting broken up, and the oxygen will take away the bond electrons, and we'll get something like CH and double bond here. Okay, next what will happen is again H minus will react, and we have some water molecule also. So this O minus will take H from the water molecule. Similarly, this carbon atom would be having negative charge because H minus would come and attack over here, so it will take again H minus from the H plus from the water molecule. So in the end we'll be getting something like a reduced compound in which we'll be having something like this as the final product. Okay, so let us see what actually happens in this case. Okay, so with all this compound we react Dhawal H, okay, and all will be reduced to RCHO. We have seen this reaction previously also in the preparation of aldehydes. Okay, next we'll be seeing Rosenmund's reaction. So Rosenmund's reaction is nothing but if we have something like a halide, okay, on this halide, if we pass with H2PDBSO4, what will happen is it will be converting into RCHO. Again, we have seen it in the preparation of aldehydes. What actually happens when we pass this compound over H2 on the plate on the surface of nickel? So what will happen is it will reduce both the double bond as well as it will attach hydrogen and hydrogen here as well as H and H here. Okay, but on the other side, if we react it with or reduce it with H2 and PD carbon plate, so what will happen is it will only selectively reduce the double bond, keeping the double bond between the oxygen atom or the keto group intact. Okay, please remember this, it is asked many times. Okay, so let's do some examples. We have this compound, okay, and first we are reacting it with LiAlH4, okay, and secondly we are reacting it with NaBH4. Okay, so what will happen with LiAlH4? LiAlH4 will reduce everything. Okay, it's a very good reducing agent. So what will happen is OH at this position, then we'll be getting OH at this position. Okay, then we'll be getting, okay, what would be the reduced form of ester? Again alcohol plus obviously ETOH of this removing group. It will also reduce the removing group. Okay, what will happen with NaBH4? Obviously you know that NaBH4 will only reduce acid, chloride, halide, aldehyde and ketone. Let me write it again. So NaBH4 will reduce aldehyde, ketone, acid, chloride and what is left? Halide. Okay, 1 degree. Okay, so just remember this. So now what will happen in the second case? This is a aldehyde, this is a aldehyde, this is a ketone, this is the ester. So apart from ester, every other group or the other two groups precisely would be reduced and we'll get something like this as our final product. Okay, so let's discuss another example. We have something like this, we are passing it in LiAlH4. So what would the product would be getting? Have H minus both the sides, will be getting something like this. Okay, this would be the final product. Okay, and why did this bond broke? Why not this? The answer is obviously this carbon atom is more partially positively charged. Okay, so coming H plus would be actually attacking on this carbon atom. Okay, let me redraw it. So the coming H atom or H minus ion attack this carbon bond. Okay, next what will happen is it will again form double bond. As a result, this oxygen atom would be getting cleaved, so we'll be getting something like this. Okay, again we'll be getting a positive charge here, and this would be stable because of our highly stable IIT cation. Okay, next what will happen is, again in water molecule, and H minus will again attack H minus coming from LiAlH4. It will get attached, it will get attached here. As a result, we'll be again be getting a O minus here, which will again be acting on H water molecule, and all the story I think you remember, and you can imagine from now, as we have done so many practice of all this reaction mechanism over a course of this video lecture and previous video lecture series. So I hope you get to this compound. Okay, so next question is, what happens when we reduce this compound? Again in LaH or LaAlH4, we'll be getting H minus here, H minus here, both the sides, or H minus here and H plus here, whatever you can say. So we'll get something like this as the final CH. So did I write the correct thing, or did I reduce it correctly, or something else would have been expected? Yes, this is not correct. As I have mentioned in the notes in the first few minutes of the lectures, the nitrogen containing compounds such as amide, cyanide, isocyanide and NO2 will convert into amine. Okay, so this will convert into amine. Okay, okay, so with this we come to an end of this lecture. So okay, before ending, let me tell you, if some of you guys have not related as to how it happens that amide actually converts into uh, amine and not this compound. So what will happen is, H minus will actually attack on this carbon atom, and as a result O minus will be getting, O will be breaking up its bond with the carbon atom and getting a negative charge in itself. Okay, we'll get something like this structure, H and NH2. In the meanwhile, water molecule, from the water molecule, OH, H plus would be taken up by the oxygen atom or the O minus, and again we'll be getting something like this. Okay, and finally the lone pair of nitrogen will come into the picture, and we'll get something like CH double bond NH2 with the release of OH minus. Again H minus will actually attack this carbon atom, and we'll get PHCH2. Again the bond pair would be taken by the nitrogen atom again, and we'll get something like this. Okay, so how will the H minus will again be regenerated in the process? Okay, so what will happen is, this OH minus will again attack on water molecule to liberate H plus, or H minus would actually, this is a reducing step, right? So somehow when we try to regenerate some of the atom, it means it was a catalyzed reaction. Okay, and if we are not the if the consumed ion or group of atom is not actually regenerated in the process, then it's a induced reaction, right? And reduction is the induced process. We discussed two processes, right? Catalyzed and induced. Catalyzed would be if the H minus, H plus or any other group which is consumed in some previous step of the reaction or during the course of the reaction will get again regenerated during the course of the reaction, or during the product formation, or during the reaction termination cycle or the end step. But in the induced, we are meaning that some of the compound H minus, H plus or any other group of atoms are actually consumed during the course of the reaction and will never be generated in the coming reaction or during the termination also. Okay, so it is not a catalyzed reaction, it is rather a induced reaction, hence H minus is again not generating in the process. So with this we come to an end of this lecture. So I'll meet you in the next lecture. Okay.